All right, so let's pick up with some additional examples of using simple interest to solve a question. So we want to buy a car which sells for $10,000. We have $6,000 to invest at 3.5% APR. How long must we keep the investment to be able to pay for the car? Well, again, I know this is simple interest because we are told that it's 3.5% APR. And if it's going to be anything other than simple, we have to be told how often it's compounded. So since we don't see anything here about compound, that tells me I'm working with simple interest. And I know that I want to use the formula that has future value because I'm told that I want to have $10,000 eventually. So that is a future value. So we're going to use our formula that FV is equal to P times 1 plus RT. And in this case, our FV is the $10,000. That's how much we want in the account sometime in the future. The P is what we currently have now, or $6,000. The 1, again, is always going to be 1. The R in this case is the 3.5%, or as a decimal, 0.035. And the T is the time, and that's actually what we're trying to find in this case. Now, in the previous example, we did what was inside the parentheses first, but notice that these are not like terms. And since they are not like terms, this is a 1, this one has a T, we cannot actually combine what's inside the parentheses. So rather than doing what's inside the parentheses to get rid of them, we're actually going to get rid of this 6,000 on the front. Well, what's the operation between the 6,000 and what's inside the parentheses? Multiplication. So how am I going to get rid of it? I'm going to divide both sides by 6,000. So 10,000 divided by 6,000 leaves me with 1.666 repeating on the left. And on the right-hand side, the 6,000s divide out and leave me with 1 plus 0.035 t. So now my goal is to get t by itself. I want to solve for t, and that means on one side all by itself. So I need to get rid of the 1. So to do that, I'm going to subtract 1 from both sides. Notice that over here on the right-hand side, the 1 has been added. So we're going to do the opposite and subtract it. And that's going to give me 0.666667 on the left and 0.035t on the right. So now our goal is still to get t by itself. The operation between 0.035 and t is multiplication. So again, we are going to divide to get rid of the 0.035. So I end up with 19.05 on the left is equal to t on the right. And remember that t is measured in years, so we actually have a time of 19.05 years. Now, keep in mind that simple interest only accrues one time per year. So actually, if we didn't have any other money that we have access to, we wouldn't be able to afford the car until year 20, because in year 20, that's when we would get the little bit of interest that we need from this 0.05 years. So we're not going to worry about that in our calculations, but just keep in mind that if this were a real life situation and you didn't have access to any other money, that you would have to wait until that 20th year before you'd actually be able to purchase the vehicle. So some observations about simple interest is that interest is calculated only on the principal. So it is not calculated in any way on the interest itself. So if you deposit $100, you're going to earn interest on $100 the first year, and you're going to still be earning interest on $100 the second year, and the 5th year, and the 10th year. Whereas compounding is going to, or compounded interest is actually going to earn on the principal and the interest. And we'll talk about that in the next video. Also notice that interest is based on an APR, an annual percentage rate, so the time is always in years. Interest earned is directly proportional to the time invested. So there is a constant positive rate of change. And that's because the amount you earn on the first year is the same as the amount of interest you earn on the 10th year, because you're only earning interest on the principal and not on any of the actual interest itself. Now, when we're working with bonds, there are some terms that can be a little bit tricky, so I wanted to make sure we looked at that specifically so that you wouldn't be thrown off when you were working with a bond scenario. Because when we talk about a bond, the value of the bond is actually the maturity value, or the FV. So if we talk about a $500 bond, that's not how much we're paying for it now. That's how much it's going to be worth when it matures. So you have to be careful and make sure that you get that number plugged into the correct spot on our formula. So let's say you purchase a 5-year bond worth $1,700 that provides 2.7% annual simple interest. How much did you pay for the bond? So remember, if it is a $1,700 bond, that is how much it's going to be worth sometime in the future. In this case, 5 years in the future. But the $1,700 is not what it costs us right now. So I know I'm working with simple interest because I have the simple interest here. And that's what's nice about simple interest. It's fairly easy to tell that you're working with it because it's going to be listed most of the time. And I know that I have a future value because that's what the $1,700 represents. So that tells me I'm going to be working with my formula that FV equals P times 1 plus RT. So now I know that the 1,700 is the future value. So FV is going to be 1,700. P, that's how much we're paying for it right now. Well, that's how much we want to know, right? I want to know how much I'm paying for it. So the P is what I'm looking for. 1 always stays 1. R is the rate, so 2.7%, and as a decimal, that would be 0.027. And T is the time in years. Since this is a 5-year bond, that means that the bond will mature in 5 years. So now all we have to do is follow our order of operations to get our answer inside the parentheses. Notice that in this case, we don't have any variables left inside the parentheses, so we can go ahead and multiply this together and get 0.135, then add the 1, and get 1.135. And now what's the operation between P and this? It's multiplication. So how am I going to get rid of it? I'm going to divide by it. So 0.1135. So P is actually equal to $1,497.80. Now you'll notice there's a second part to this question, because not only do we want to know the the current cost of the bond, but we also want to know how much interest is going to be earned. Well, if you think about what we have, we know that the bond has a future value of $1,700, and we know that we paid $1,497.80. So the interest is going to be the difference between these two values. Because if this is how much we paid and this is how much we're going to get at the end, then the difference between those is the amount of interest that we earned along the way. So if we take 1,700 and subtract 1497.80, we will get the interest earned, which in this case is $202.20. So remember, the keys with simple interest is that you have a couple different formulas that you can choose from. You can choose from I equals PRT, and you're going to use that formula specifically whenever you're just looking for the interest. And you can also use FV equals P times 1 plus RT, and you're going to use this formula whenever you're looking for the future value. Now you'll notice we did use this middle formula because this is how we knew to subtract the future value minus the principal in order to get the interest. But most of the time we don't have to think of it in terms of a formula. We can just think of it in terms of what do we have and what are we looking for. Remember that in any formula we use in financial math, R has to be written as a decimal, and also remember that T is going to be in years.